Exercise 10, Event Models of the form, frequency times severity equals risk. Now we run into a different type of problem. We want to create a distribution function that quantifies the total number of days with a snowstorm during a certain year. We can split this problem into at least two components. On any given year there is a certain number of snowstorms. Also, each one of the snowstorms lasts for any number of days. Therefore, to obtain the total number of snowstorm days a year we could use the approach of multiplying the number of snowstorms per year times the average number of days of snowstorms in order to obtain, at least from a starting point, a quantification of what we are looking for. From the standpoint that the number of total annual days a year of snowstorm is the risk defined, it is the amount of harm that can be expected to occur during a given time period due to specific harm event, for example, the snowstorms. Statistically, the level of risk can be calculated as the product of the probability that harm occurs, the total number of snowstorms occurring during the year, multiplied by the severity of that harm, in other words, the average duration of snowstorms. Therefore, for this example, consider a frequency times severity equals risk approach. There are, on a long-run average, 6.5 snowstorms per year. Each snowstorm may last from half a day to 6 days, with a most likely duration of 1.5 days. Knowing this previous information you might be able to calculate how many days of snowstorm a year there are. 1. On cell B73, insert a Poisson distribution that counts number of events with the formula, equals risk Poisson B72. On the long run, 6.5 snowstorms will be generated after a simulation. A Poisson distribution always returns only integer values, with a mean and variance equal to its only parameter lambda. It is usually used to describe, for example, the number of individual events that occur in an interval of time when the events are occurring at a constant rate. For example, customers arriving in a queue, accidents on a road, or imperfections per meter of carpet, the number of items in a batch of random size, the number of items needed from an inventory, the number of periods, months, days, a device is out of service or the number of claims in an insurance policy. It assumes that the time between failures has an exponential distribution, which means the number of failures occurring in a small interval of time is constant. 2. To quantify for the severity, insert a PERT distribution on cell B74, given the three parameters provided by expert opinion, equals risk PERT B75, B76, B77. 3. On cell B71, multiply the frequency, the Poisson distribution on cell B73, times its severity, the PERT distribution on cell B74. 4. Declare this cell as an output by clicking on the Add Output icon of its risks ribbon. Change the suggested name on the window to snowstorm days per year. The cell should now look like this, equals risk output snowstorm days per year, B73 times B74. 5. Proceed to simulate 10,000 iterations. Sometimes running simulations may generate slightly different results based on any number of conditions being set up on your model. To guarantee that any given model generates exactly the same results on its outputs, check for the following. A. The number of iterations is the same. B. The number of input variables present on the model is exactly the same. C. The seed value has been placed at the same integer number. D. The generator algorithm is the same. E. The sampling type is the same. Some of these conditions are defined in settings. We discuss this issue in modules that deal with convergence topics. 6. After the simulation, a graph such as the following allows for additional interpretation. If we consider a relatively strong or harsh winter, with at least 20 snowstorm days a year but less than 30, then we could say that there is approximately 14% chance of such a winter. In other words, approximately in 1 every 7 years such a winter occurs. If we were to define a very extreme winter, one that has more than 30 snowstorm days a year, then we would say that there is a between 4% to 5% probability of such a winter. In other words, this type of winter happens once every 20 to 25 years. However, we will demonstrate on the next exercise that this probability assignment may be too conservative, and extreme winter years may not be as probable as this first approach describes.